Hey viewers, I'm back again, and in this video we are continuing with question 11A11. Okay, remember we had paused in the previous video, so shall we continue? The question A11 says when you have a lot of calculations in your mind, you pronounce them even when you are looking at calcium. Calcium carbonate thermally decomposes to form calcium oxide and carbon dioxide gas according to the equation. It's true. And what do they mean by thermally? They simply are talking about the fact that it's been heated. There is some addition of heat as a way of decomposing it. Okay, so we have this equation, calcium carbonate in solid state decomposing to calcium oxide and the carbon dioxide gas. Is the equation balanced? That's the first question. Yes, it is. Now we're taught that 8.0 grams of calcium carbonate was strongly heated in a crucible, and 3.4 grams of calcium oxide remained in the crucible. Okay, so there was this heating process, and then calcium oxide remained with a mass of 3.4 grams. And what was the percentage yield of calcium oxide? Well, here we are going to basically do some calculations here. So what you need to understand is that when you are asked to calculate the percentage yield, there's some information that you need. Number one, you need the actual yield or actual mass in this case. Then you need also the theoretical yield, and this yield is also its mass. Then that's when you'll be able to calculate the percentage yield. Okay, so now in this situation, what have you been given in the question? Well, the question is saying that 8 grams of calcium carbonate was strongly heated in a crucible, and 3.4 grams of calcium oxide remained. Whose percentage yield do they want? Calcium oxide, not of calcium carbonate. So we've been given this mass. So between the two, actual mass or theoretical mass, which one does this belong to? Well, I must tell you that this is the actual mass. This is what remained in the crucible after heating. But the theoretical mass is the one that you are supposed to calculate. Okay? I'll give you an example. Let's say you are a farmer, and then you use the calculations based on the 10 kg seed that you have bought, the calculations of how many bags you are going to harvest at the end of the season. So when you do the calculation based on what the amount of fertilizer that you are supposed to put in, the amount of land, the size of land that you are going to use, and the amount of the number of bags each line is going to give you, that is theory. That is not practical. Okay, you are basically theorizing, but the number of bags that are going to be produced, and that is because you have done your farming properly, and maybe because you have not applied the amount of fertilizer that was needed to each to each plant and all those things. That's now practical. Okay, so that you are actually doing the farming there. When you are planting, maybe birds come in, they chew some of the seeds. That is practically now, and the number of bags will be dependent on how well you are going to do the farming. Okay, but they may not be as much as you had anticipated them to be when you were theorizing. Okay, so the actual mass is basically what remains, and what remains may not be equal to what you are theorizing or what you have theorized because of some of the factors that may take place. Some of the products escape as gases, some of them, they have impurities and all those things. So the actual mass is basically given in the question. And then what you're supposed to calculate is what we call theoretical mass. So now, let's calculate the theoretical mass. How are we going to calculate the theoretical mass? Well, we're going to use calcium carbonate. We're taught that calcium carbonate thermally decomposed to calcium oxide and what? And carbon dioxide gas. So what are we going to do here? What we are supposed to do is to use the 8.0 grams that were given in this question. So what is the relative formula mass for calcium carbonate? We know that calcium is 40 plus 12, that is 40 plus 12, that is 52. 52 here we have 16 times 3, that is 48. 52 plus 48, that is 100. Okay, here calcium oxide. Why are we picking calcium oxide? Because it's the one we are basically concentrating on, and whose percentage we are calculating. We don't care about carbon dioxide. Okay, but there is also a law that we need to observe, that the law of conservation of mass. The mass here must equalize the mass this side, the sum of these two. Okay, so here we are observing that law to ensure that we arrive at the mass that we are going to have, the theoretical mass. So here we have 40 plus 16, that is 56. Now, what is the mass of calcium carbonate? We are told that is 8.0 grams. What is the mass this side? Well, we don't know. We can just do an equation there, and we're going to say x is equal to 56 times 8 divided by 100. And what we're going to have here by using our calculator is 8 by 56. The answer there is 448 divided by 100, 4.48. So 4.48 grams. Let's pick it the way it is, because we're going to use this to arrive at the answer. Now what we have here now is 4.48 as the theoretical mass. Can we use the formula? Yes, we now have both of these. So percentage yield is equal to actual mass over theoretical mass, multiply this by 100%. So what is our actual mass? 3.4 grams divided by 4.48 grams multiplied by 100. And what are we getting? So we're going to say 3.4 divided by 4.48, 3.4 divided by 4.48, multiply this by 100. We're getting 75.89. So if we round this one off to one decimal place, we're going to have 75.9. If we round off this one to a whole number, we're going to have 76%. This is what we get. We go back to the answers. 76%. So the answer is A. Question 11. The answer is A. We move on to question 12. Excuse me. We are told that hydrogen peroxide solution decomposes very slowly at room temperature to produce oxygen and water. It's true. But in fact, this is one of the ways in which oxygen is prepared in a laboratory. And the catalyst is it manganese oxide as a catalyst, if I'm not mistaken. Yeah. Apart from increasing temperature, suggests the best way the reaction can be speeded up by increasing concentration or increasing light intensity. Surface area is a solution using a suitable catalyst. Yes, manganese oxide. So the answer is D for question 12. Question 13. The diagram below shows the electronic structure of an ion of element L. So we have L here. This is element L. Now, this element L, it is an ion. It has lost 3 electrons. So initially, it had all the 3 electrons before it lost them. That's what it means. So in this case, how many shells does it have? It has 1, 2, but when it was an atom, it had 3 shells, the one which had the 3 electrons, the electrons which it has lost. So L, the electronic configuration is 2, 8, 3. And we can tell that L belongs to group 3 because of the valence electrons, and it is in period 3 because of the 3 shells. Remember, groups are determined by the valence electrons, while periods are determined by the number of shells. So we go to the question. To which group and period of the periodic table does element L belong? Well, it's group 3 and period 2, no? Group 3 and period 3, yes. The answer is B. Question 13, the answer is B. We move on. Question 14. Which is the electronic configuration of a noble gas used to provide an innate atmosphere in iodine? The one that does this is actually argon. Apart from the fact that it also provides a suitable atmosphere, or an innate atmosphere in bulbs. It also does that in water. Now, who is argon here? Well, when we go to the periodic table, we find that argon is in group 8. So we have this one, it has 18. So the first shell is going to have 2. The second shell is going to have 8, and we're remaining with 8, and the third shell is going to have 8 electrons. So it has 3 shells, and that's why, if you can see here, it is in period 1, 2, 3. Okay, so that was just beside the point. But what we're looking for here is the argon. Where is argon? It's this one, 288, which is B. Question 14 is B. Move on to question 15. Metal Y was added to iron 2 sulfate solution, and the solution changed from green to colorless. What is the identity of metal Y? Of magnesium, silver, gold, and copper. All right. How do you answer such questions? Such questions are answered intelligently by knowing the reactivity series. Where we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, then we have silver, and we have gold. Okay, like that. So now, iron, where is iron? Iron is here. Any metal which is below iron cannot displace iron because they are less reactive than iron. But anyone above here can displace iron. That's what the question is just talking about. But they can't come out like this because they know you will definitely answer it in a very short period. So they want first you to get confused. So here the thing is, you need to identify metal Y. So copper is here below iron, this one. So copper cannot displace. Who else is there? Gold is even not reactive. Who else is there? Silver, but who can do that? Zinc, aluminium, magnesium. So the answer is what? A. Question 15, the answer is A. We move on to question 16. The diagram shows the main stages in the manufacture of ammonia-based fertilizer. We have nitrogen and hydrogen reacting in the presence of the pressure of about 200 atmosphere and the temperature of 500 degrees Celsius. It's actually about 450 to 500 degrees Celsius, and iron as a catalyst. So now these are forming ammonia here. Then there is a process where we have this separation. Now there is this again which comes back to here. Now what you need to understand is that hydrogen and ammonia react to form ammonia, but this process is reversible, meaning that as ammonia is being formed, the same ammonia is reversed, okay, or is turning into hydrogen and nitrogen. And this is what we see at this point. We have the nitrogen, which is not reacted, and hydrogen coming back. It is retained here so that it can react, the process continues again. So now, what is the question saying? What is happening in the process labeled Y here? Well, ammonia is returned to the start of the process to quicken the rate of reaction. And if you are a bit confused, you can go for this. But what we know is that ammonia remains here. What comes out are the unreacted hydrogen and nitrogen gases. B, gases are cooled to cause ammonia to form a liquid. It's a lie. C, unreacted hydrogen only is recycled. Woofy. D, unreacted hydrogen and nitrogen are recycled. Yes, question 16, the answer is D. What about question 17? Methane is reacted with steam in the presence of nickel as a catalyst to produce gas T and carbon dioxide. Well, in this reaction, when you react methane, CH4 plus steam, what you are producing is carbon dioxide plus hydrogen gas. Apart from reacting a reactive metal with an acid, you can also produce hydrogen by passing steam in methane to produce this. And nickel is used as a catalyst, okay? Or nickel. So now, this gas that has been produced is the one we are calling as gas T from this question. What is the suitable method of collection for gas T, and the reason? Well, gas T can only be collected by this process, delivery, looking up, facing upward like this, which is, this one is called upward delivery, okay, or downward displacement of air. This one is called the upward delivery. And the reason is that this gas T, which is hydrogen, is less dense than what? Than air. That's the reason. We go back to the answers. Upward delivery, reason because the gas is more dense than air. Let be perfect. B, upward delivery because the gas is less dense than air. Yes, this is the answer. Question 17, the answer is what? B. We move on to question 18. Question 18 says, pollutant gases are released by the bacterial decay of vegetable matter. Which gas is mainly sourced from decay of vegetable matter? Well, it's methane. Yeah, it's methane. And the answer is B. Question 19. Butane can undergo an addition reaction with steam to form compound R. Okay, and the compound here. So let's write the equation that we're talking about here. We are told that butene, not butane, but butene, which is C4H8, is a gas, reacts with steam, okay, to produce, the product is an alcohol, a corresponding alcohol, which is C4H, H9OH. This is the butanol. So apart from, and this process, before I say it, this process is called hydration of butene. Hydration of butene. But the process of making an alcohol is called hydration of alkene. This one, this process. So what is the name of compound R? It's butanol. B. Question 19, the answer is B. We move on to question 20. Question 20 reads as follows. Polymers are made using monomers. It's true. The following are structures of some monomers. We have this one, which is 1, 2, 3, which is the propene. Then we have this one. This one is a diol, okay, because it has two functional groups of alcohol. This one is a diamine. We have the amine groups at the end. Then we have a dioic. This one is the carboxylic acid or dioic, because it has two carboxyl groups on both ends. So now, identify the correct set of monomers that form a polyamide linkage. Just before the exams, I did a lot of videos on this, and on past papers, and I think I also did a video on this part. Now, polyamide linkage is produced when a diamine is reacted to a dioic. So you have diamine plus dioic, which gives you, what does it give you? Well, it gives you a polymer, which is a polyamide plus water. And this type of polymers or macromolecules, we call them condensational polymers. These ones here, I should have put polymer here. Polymer, okay? And this is the process through which nylon is formed and the protein, okay? Yeah. So now you have a situation where you have this, okay? Maybe let's just use 3 carbons. We have NH, H here, and we have NH and H here, okay? When you react this with a dioic, which has this OH, and we have OH, like so. What is going to happen is that a water molecule will be formed here. These two, they will form a water molecule. And what you end up having now is this. 1, 2, 3, NH. This one, this bond will come here, be attached, which is this one now. We will have a C and an O there, oxygen, then you have C, and then you have C like that. It continues just like this to this one. Now, this one here is the one we are calling as amide linkage. And because there are many of these linking up these monomers, we call this one as a polyamide molecule, okay? Because of that. So now, which one can do that? So remember here we have hydrogens. I just input them. We have hydrogens here, okay, like this, H, please don't think politically. So this is what we're going to have. Yeah, like so. So this one is the amide. So when we go to the question, which one can suit this presentation here, or which can lead to this? So we have this one, no? This one is a dioic. We're looking for diamine and dioic. This one is a dio. So this one is a diamine, dioic, which is Y and Z. They are the only ones which can produce a polyamide linkage, and this is Y and Z. So the answer for question 20 is A. Okay, viewers, I hope this has been helpful, and I believe that you will be anticipating for more educative videos, which I promise to do. And like my videos, subscribe to my YouTube channel, share, and refer this to your friends. And I must also emphasize that I'm now under Barath Academy. Of course, I'm Mr. Nyati, the presenter under Barath Academy this time around. And if you've noticed, the name has changed from Mr. Nyati Online to Barath Academy, which is basically an online platform to champion online education, and also doing more of revision and giving you what you basically dire for and what you hunger for. I hope this video was helpful. Thank you. Bye bye.